Great, thank you guys for joining today. My name is Erin Smith. I'm the program manager for alumni events at the College of Engineering and Applied Science. And I'm excited to be kicking off our very first webinar in our new alumni webinar series. In this series, we aim to showcase some of the amazing work that is happening at the college, and we really want to bring faculty directly to you so that you can get an exclusive look into their work. We are very grateful to the Atlas Institute today for partnering with us on this webinar. And I know our three faculty presenters have some very exciting and inspiring things to share with us. Now it's my pleasure to introduce the Associate Director of Atlas, Jill Dupre, who will be our moderator for this webinar. Jill conducts research on technology policy, including privacy and telecommunications. Prior to working at Atlas, she was a research fellow at the Silicon Flatiron Center for Law, Technology, and Entrepreneurship at the University of Colorado Law School. She's a member of the Colorado Bar Association and received a JD from the University of Colorado Law School. Thank you to all of our faculty presenters for taking the time to share your amazing work with our alumni and friends today. Jill, I'll go ahead and turn it over to you.
Thank you, Erin. I wanted to start today by asking you to imagine yourself in the before COVID times at a party, and the people there have wildly different areas of expertise: computer science, biology, chemistry, textiles, robotics. And within that group, you have people passionate about body art and tattoos, games, art, fashion, volleyball, paragliding. And they're genuinely curious about you and your expertise, your passions, your ideas. You get absorbed in the energy and enthusiasm of the people you meet there, and in their desire to find ways that their interests intersect with your own. As the Associate Director of the Atlas Institute, I love being part of the Atlas community of faculty, staff, students, alumni, and supporters who make it feel like that party every day. I'm grateful to have had a chance to share some of the exciting work in our community with you today. Atlas is an institute for radical creativity and invention. At CU, the institutes were designed to cut across disciplinary silos of departments. The institutes are primarily engaged in research, which means everything from atmospheric and space physics to behavioral genetics. Atlas is unique among the institutes in that we have a PhD, master's, and undergraduate educational programs, all housed within the College of Engineering and Applied Science. We pride ourselves on engaging students from each level in our research because we believe it creates a richer educational experience and more interesting research. We ask faculty and students to bring their passions with them. So for a student who's passionate about music, their project in a class on wearable technology might be gloves to teach people to play the piano. For a faculty member with expertise in chemistry and a passion for body art, that might mean tattoos that change color based on inputs like blood sugar or the presence of UV light. This approach is working. Our academic programs at the BS, MS, and PhD levels are growing. I already saw a question that one of you submitted about efforts in diversity and inclusion. And I'd say that encouraging our faculty and students to bring outside passions and interests is part of the answer. We have over 50% women or non-binary students in each of our programs and exceed the campus averages for underrepresented students. And we think that's largely because students find their way to work on things that they care about. Looking forward, we expect our Center for Media, Arts, and Performance and our Black Box Studio to attract a more diverse demographic of people than typically show up in conventional engineering disciplines. That isn't enough, and we're embarking on greater efforts for diversity as part of our recruitment processes. And because money is part of the solution, we've begun fundraising for scholarships with the goal of greater diversity. Our faculty have also been working to ensure that their syllabi feature diverse sources and viewpoints. Today, we're thrilled to have 3 faculty members to discuss their research and the work in their labs. We'll have a few minutes for audience questions following each presenter and then time at the end for follow-up questions, but please feel free to be typing questions throughout the event. We'll begin with Laura Devendorf. Professor Devendorf directs the Unstable Design Lab. She earned her PhD at UC Berkeley School of Information and has worked in the fields of sustainable fashion, design, and engineering. Her research has been featured on NPR, and she recently received a prestigious NSF Career Award. She is an artist and a technologist working predominantly in human-computer interaction and design research, and will share some of her recent work on smart textiles.
Thank you, Jill. That was very kind, and I will get my presentation set up here for you. All right. You're on my other screen, so I'm going to pull your faces back here. Everyone see my big screen and not my notes? Great. All right, thank you so much for joining us today, and I'm excited to be telling you about the Unstable Design Lab, which is a physical space in the Atlas building and also a collective of people. So we are on the second floor. We're just outside the elevators, and this is a photo that I believe actually maybe Mark even took at one of our faculty meetings in the summer of 2019. So what I like about this photo is recently some of the undergrads we work with pointed it out as what they think best represents the lab, and I've been looking at it differently since then. But what's nice about it is it highlights the various perspectives that come into the space. And so we have a lot of undergraduate researchers, visiting scholars from different countries or from different university programs, scholars from both the humanities and engineering, all coming together to work on not only what kinds of technology we can build, but what we ought to be building to create better futures that are both social and technical. So not just new tech, but new kind of futures that imagine new ways of cooperating with each other and more equity. So the structure of the lab, I like to use this kind of animated GIF of starlings, because I don't see it as a top-down lab where I necessarily direct all the projects so much as by bringing all these different perspectives into the space, we're able to kind of morph and follow each other. And that's the essence of the word unstable in Unstable Design Lab, is that we're always kind of adjusting and moving around each other's shifting interests and influencing each other. So go back this picture, and to do the thing you see in all the movies where we enhance and enhance, I want to show you what's on the table here. And what's on the table is a smart textile. And that's largely the work that has been holding a lot of us together in the lab. So on the left, you have a traditional circuit board. And what a smart textile is it's a different kind of circuit board that's created out of textile materials and using textile structures. So it's something like this, and you can crumple it up and you can throw it, and it's lightweight and it's soft, and you can make them quite visually appealing. And so there's been this growing interest in smart textiles, and it's this area that people are pointing to as one of rapid innovation. But there's this big bifurcation in the kind of work that's happening in smart textiles. There's this typical kind of engineering approach where we make a new material in a lab and we throw it into a basic textile structure just to show that you can weave it or knit it. The approach we might be a bit more interested in, or interested in bridging with that engineering approach, is a craft-centric approach. And so this has really been emergent out of craft communities over the past 2 decades, largely by people who we don't associate as being part of technology. So largely women and underrepresented groups have been doing this work for a while, but it hasn't necessarily been called engineering. But what I'd like to do is create a space in the lab where these 2 communities are mutually respected and can start learning from each other's. So what's interesting about this craft approach is that it's not just about the new materials, but about leveraging textile structures to make really robust forms of sensing and actuation. And what's exciting is that the history of weaving is longer than recorded history. And so this is actually a depiction of Athena and Arachne weaving together. So there's 30,000 years of innovation in textiles that when we think about disruptive tech, it's always creating something new. And textiles show us that there's amazing value in looking at the histories and traditions and machineries that have always been around, that inform so much of what we interact with daily, and that actually form the basis of modern day computation. So a few examples of the smart textiles we're making in the lab. The structure on the left is a typical force sensor, so it measures how much pressure you're putting on something. And the structure on the right is something we've developed in the lab with resistive silver and copper and wool, using a 2-pick bird's eye structure for the weavers out there that actually compresses when you put force on it, giving you the exact same functionality as that rigid force sensor. The second project, and the one that you actually see on the table in our lab photo, is a reinvention of an electrode. So an electrode is used for physiological monitoring. And typically they're adhesive and they stick to your skin, and they're not particularly comfortable for long-term wear. And so a student working with us in aerospace and an artist in residence came together in the lab to develop a new form of electrode that uses a technique called double weaving, silver yarns to pick up the electrical signals, and wool to actually wick moisture from the skin to ensure that the readings aren't too noisy. So looking to textile materials and structures to do the work that we would normally delegate to something like adhesives. So the idea is that this can maybe fit seamlessly in a VR helmet or in a space helmet, measuring something without the use of our hands and giving us the kind of physiological feedback. All right, so zooming back, another thing you might notice if we zoom in is that I'm making a really awful face in this picture, but just above that is a whole bunch of descriptions of a piece of software that we're building. So the piece of software we're building addresses this challenge that textile designers and people who design circuits or electrical engineers don't often speak the same pattern languages. And so the pattern language of textiles is something like this. It's basically a grid that shows you where the material goes above or under the other materials. This is a circuit diagram. So it doesn't actually really tell you anything about the material so much as the structure and the geometry of the components involved. So we've built this software with support of the National Science Foundation to bridge these communities that allows you to design both in the language and histories of weaving while adding overlays for circuitry. And by privileging the weaver's perspective here, we did this as an equity move to make weaving and its many histories on par with the kind of new technological things that we're doing with these. And we're doing a lot of outreach right now to hand weaving guilds and the local hand weaving community to get further support for their inclusion in these innovation practices. Another thing we do is we host a weaving residency where we bring someone in to solve these challenges. So the idea is that we team up and we build things and we put them in the software, and then they're free for everyone else to use. And the nice thing, especially during COVID times, is that you don't have to have the most high-end machinery to realize these designs. You can do them on a school loom you might have used in elementary school. So just to conclude, the lab is a space where we privilege history, where we're thinking about not only what to build, but how to build, and we're also thinking about the sustainability challenges. So thinking about how we actually take these textiles apart, not just how we make them. And with that, I'll say that it's not necessarily about what we invent in the lab, but how we invent it and who's involved in that invention that we believe will create a better future. So with that, thank you. And I'll play the video of Chanel unraveling the textile during the Q&A, just because it's long and it really, for me, exemplifies the embodied feeling of working with yarn.
Thanks, Laura.
Thank you.
And so any participants, you are welcome to enter questions in the Q&A. I don't see any quite yet. Okay, thanks. Maybe we'll save questions for the end. Thank you so much, Laura.
Thank you.
and I'll let you stop sharing, but maybe we'll make you show the video again later. Okay, so next we have Professor Ellen Du. Professor Du speaks internationally on design and technology. She holds a PhD in design computing from Georgia Tech, a Master of Design Studies from the Harvard Graduate School of Design, and has served on the faculties of the University of Washington, Carnegie Mellon University, and Georgia Tech. Before coming to Atlas, she co-directed the KO-NUS CUTE Center in Singapore, a research unit investigating connected ubiquitous technology for embodiments, CUTE. Professor Du and her students invent at the intersections of people, design, and technology. She works on computational tools for design, especially sketching, creativity, design cognition, including creativity support tools and design studies. Most recently, also computing for health and wellness. So I'll turn things over to Professor Du.
Hello, hello everyone. Okay, let me share my screen. Thank you for the introduction. All right, can you see my screen? Yes, okay. So let me share with you some of the projects from my lab. It's called the ACME Lab, ACME Creative Machine Environment, because people are creating machines and we also like machines to be creative. And one of the things we explore is also thinking about everyday objects as interfaces, that things you can create and you can interact with computational technology. And for example, this one is called the Mega Magnet. And as you can see here, this is our 3D printed, but embedding magnets. Yeah, depends on how you embed it, you can have different tactile feedback. So this one is putting in an angle, so you can create switches, yeah, like a light switch. So I can go out, there are many gadgets that we have designed. And so the idea here is not just to order something online, we have to fit it into our design, is that you will be able to create anything that you can think about, right? So you think about the magnet, you can put them attracting or repelling, you can arrange them linear, polar, angular, and then you can come up with a map of how you put things together, right? So we can see, we can do things putting magnet attracting or repelling and different configuration, even though they may look similar, the rounded shape or bar and boxes, but their interaction will be very different. And this is like, when you print it out, you can embed them, you can do different things. And so one of the first questions people ask, oh, this is so cool, I can make it design for anything. And one of the obvious things is to make game controller. So here you see this is Peter and Clement. So both of them worked on the Mega Magnet project to expand that into a game. So they do the 3D printing gadget. They also designed the game mechanics, and they went to this GDC. That's one of the largest game design conference, have 4,000 people. And they presented their things, and a lot of people play with them, and they won the best award for the alternative control because they could pretty much give people the freedom not to do existing controller, you can build yourself. And this is the game I'm sharing with you. Okay, so as you can see here, everything here is start from scratch. You can see it's 3D printed, and the game is like this ship going on the ocean and all hands on deck because you need your hand to move things around. Okay, so on the ocean you have one ship, but you have 5 inputs and 2 players, left and right. And you need to swap and collaborate because you're controlling either the right-hand side or left-hand side of the ship. Yeah, so individually you can see, okay, for this is a crank, you change the sail, you can change the speed for the ship. And the helm, you can be controlling and navigate which way you're going. And then of course we have the cannon. 1, 2, 3, loading it. And then we have a fuse fire. Okay, so you're attacking the pirates, but you may get hit by the other pilots, so you have to put out fire. So that's it. 5 input. Yeah, you have to switch and swap between your partner, collaborate, because you're doing different sides. So when we presented at the game, lots of people come back, parents, partners, and children, they come back again. Yeah, so it's a lot of fun. So one of the power is that being able to do it, starting from the game, for the mechanics, and everything is all your own design. Okay, and then this is extension like, hey, what if we don't have 3D printer? Can we also build something with paper? Can paper be an interface? So this is like a coated, carbon coated paper that people can use, and we can etch it to have pattern and put it in different places. We can sense whether the object is folding or bending. Right, so you can also make interesting like lantern kirigami, and that could be interface. The computer can be sensing you are squeezing it or pushing it. Folding, yeah, bending it or folding it. Right, so those are just the taxonomy or language of what you can do. This is an application. This is a lamp. So imagine you pulling one side and dimming the light, and pulling the other side, make it brighter. Right, so think about paper could be interface for elegant solution, how you may want to work with your environment. Yeah, and then here's another one. This is also on paper, but this time we actually have printed markers. So instead of thinking about complicated, expensive equipment to do augmented reality, we could be using simple printing paper with camera to do interactions. So here you will see, if you print the markers, and CV here is the computer vision, what computer can see. So you could have the marker print it out on the pop-up, folding it together, and when you assemble it, the interaction could be completed the marker or not. So this is setting up, like for example, if you put a camera and then having a plastic glass and then having your marker on top, you could be sensing it. And this is a pop-up button. So when you push down, you sense it. You can trigger an event. So here's some applications. So this one is literally information visualization and physicalization.
Company A sold 20 apples. Company C sold 30 apples. Company B sold 1.3 times the amount of apples as Company C. Company X started the fiscal year at 22 points. Company X decreased by 36% in the second quarter.
Right, so you could be interacting with information with simple paper without complicated equipment. And this is the pop-up book for like the play theory about the continent. So how you can see the simulation when you're pulling off and the different forces, maybe squeezing to change the landscape. Yeah, so here's another prototyping. So imagine controlling MIDI, musical instrument. So computer is seeing the marker behind it. You can push, you can map that to different things, different key, and you could have a slider so you can see the markers being detected. And you could be changing the volume or the speed by sliding through. Okay, so without a complicated, expensive keyboard, we can build things with just paper. Yes, of course, paper, you can tear it, but you can quickly replace it and do another one. Okay, so some of the idea is about everyday objects. So paper is something available, and next project, one more project to show you. This one's called Jump Station. You probably already figured out there are PVC pipe, there are buckets, and there are different things. We put together with the LED lights. When people are in sync, then the lighting is showing up. And this got selected for the Boulder Public Library and Makers Made because people find out that, hey, what people can make. So one of the things that we are curious to know if there's a happiness index. Can we have it when people are jamming together? We know when they're in sync, and can we make sure that people are happy when they engage in music and other things? So that's a quick tour of the Acme Lab, and I'm happy to answer any questions, or contact me at ellen.du@atlas. Thank you.
Thanks, Ellen. I think I'm going to pause 1 extra minute because I cut off the questions for Laura a little quick, I think. Okay. I think maybe this is going to be easier with questions at the end. And so I am going to turn things over to Daniel Leithinger. Professor Leithinger creates shape-changing human-computer interfaces that push digital information past the boundaries of flat displays and into the real world, something that we're all longing for in these days of endless Zoom. Motivated by the belief that computers must embrace the dexterity and expressiveness of the human body, these interfaces allow users to touch, grasp, and deform data physically. Professor Leithinger received his PhD at the MIT Media Lab. He has received design awards from Fast Company, Red Dot, and IDEA, and has exhibited projects internationally. Turn things over to you.
Thank you so much, Jill. Can everybody see my screen? Works? All right. So yeah, I would love to share some of our projects at the Thing Lab. And Jill already gave such a great introduction, but we're a group of artists, designers, and engineers. And here are a few of our current members. There are many more in the department that have come and gone, but I'd like to point out that some of the projects, in addition to all the wonderful students that we're working with, have been done by Ryo Suzuki, who just graduated and is now started as a professor at the University of Calgary. So big shout out there. But where the motivation for us comes from is really, as Jill said, this kind of horrid world that we're stuck in right now in front of our flat screens, where we go from one call and one video to another, and the body kind of takes a step back. And we wanted to create interfaces that blur this boundary between the virtual distant world and the physical world that we live in, and hopefully in the process make computation more accessible, more enjoyable for everybody. So for me, this started with shape displays. I'm just showing 2 examples here for those of you who are not familiar with what a shape display is. This idea, could we create a computer screen that, rather than only showing information, can actually render physical shapes? Think of it kind of like a super fast 3D printer that can like keep changing physical shapes that we can touch, that we can interact with. So what you see on the left here is a project I did as a student myself, where it's kind of like Zoom, but a Zoom you can reach out of the table and actually manipulate an object over a distance. My students and I are thinking a lot about what would be the next generation of shape displays like that. How could we make them more mobile, cheaper? You see these examples here are like big clunky tables. So we want to have something that we can actually spread out in the world, and that may affect our whole environment, not just like a little tabletop. So I'm going to show 3 quick projects that we built. The first one, and that's a collaboration actually with Professor Ellen Du's lab. So you see there's a lot of interaction actually between labs here at the Atlas Institute as well. But this project called ShapeBots, our idea is, what about, rather than building a big table stuff it full of motors, could we like have swarm robots that are on top of a tabletop? And that will render information like that. So when we want to have, say, a bar chart on our table, these small little robots, we can bring them out of a suitcase, or we put them on the table, and they will assemble autonomously to render that information for us. And now what we can do is really reach out, touch that information. So we can't just see it, we can actually directly interact with it with our hands. And for that, we built new linear actuators that are highly extensible, but also very lightweight and cheap and easy to build. So each one of these robots is only $40. And we played with this whole design space of what could we do, like put origami or put folding actuators on top of it to create a really expressive, rich, what we call like taxonomy of shape-changing designs. So here's a couple of applications, for instance, a data physicalization. So we see a map and we want to have population metrics, or maybe now data on like polling with the upcoming election. And we really want to like see that and experience it and interact with it. Or we could have them just do like little practical things. So here we have like little cleaning robots that clear the table for us before, so we have the table free. Or we could also augment existing objects. So here the robots sense that this cup is going to be too hot for me to touch. And while I absent-mindedly read this book, they actually create a little barrier to make sure that we're safe. And then a minute later, this barrier starts disappearing. So they can really, we're really thinking about this. What if we had these like swarm of robots that could go out and make our environment interactive for us and really kind of add computation to it. We were also thinking about how could we do this at different scales. So we were talking about tabletops earlier, but what if we could modify like a whole room? So this project here, Lift Tiles, we made these pneumatic actuators. And here you see Ryo Suzuki, whom I mentioned earlier. He was the lead on this project during his PhD. And he built these very compact little tiles that are cheap, easy to assemble. You can reconfigure them and you hook them up to a compressor, and then they're computer controlled to make a room-sized shape display. So you can use that for things like virtual reality, where you can actually be in an environment and as in VR, and as you see digital information, you can also touch it. So you see here, one of our users is in VR touching a table, and the environment will actually inflate these actuators to create a proxy object. And we can work with that on different, so the actuator is kind of this basic building block. We can use it on a floor. We can also build it into things like walls to have like a display that will come out of the wall. So here you see an example where we're saying maybe this could like form room dividers rapidly, or an information display. So now we know we have to go to the right here. That brings me to the third project, where we were thinking, could we take this idea a little bit farther of being in a virtual environment where in VR, we have a very rich graphics. We may have richer ways of interacting with each other over a distance. If we use an environment like Mozilla Hubs, for instance, where we can really like see each other's body, but we can't feel anything. And we were saying, could we combine this idea of room shape, haptic feedback, so haptics, the sense of touch, and swarm robots? So we built a set of 9 robots that can move around in a room and move around furniture and objects. So what these do is they're modified Roombas. They're quite fast. And then we built these vertical kind of scissor lifts that we made out of Target laundry racks, reappropriated. And so we have 9 of these. Each one of them is quite simple, but together they can create a really interesting, rich virtual environment. So here, for instance, we see a room with walls and the robots will rearrange these walls as we move along. Or I'm an architect, I want to experience an environment and reconfigure it. So I move a virtual chair and the physical chair will move along and I can actually sit down in it and experience the environment that way. And here we see kind of this like choreographed dance that these robots are doing in the basement of the Atlas building, where we have a large motion capture system to really like kind of like dynamically keep recreating a VR environment for us, so we have a rich experience. And that brings me to the end of the talk. There's a couple more talking points we can discuss, and I can pull them up later in the Q&A about what's ongoing right now, what we see as the next steps to making these tools really enrich how we can communicate with each other in these times of social distancing, and also what we think are the technical challenges to really making this happen and rolling it out. So how to sense, how to design, and how to integrate new actuators. But for now, I'll take it over to Q&A, and thank you so much.
Thank you so much, Daniel. I hope all of these presentations gave you a sense of the interdisciplinary work that's happening in Atlas and the opportunities that students have to engage in this really exciting research. You heard from 3 lab directors today. There are 8 others in Atlas and growing. And so at the end, we'll give you an idea of how to learn about those labs as well. But for now, we're going to start addressing some of the questions that we've gotten. And in case you haven't used this format before, at the bottom of your Zoom screen, there's a little Q&A icon that you can click on and type questions for us to see. But I think I'll start with, I hope I'm pronouncing this correctly, Karen's question about, has there been research into combining smart textiles and other tangible sensors such as pneumatics? And I'll turn that over to Laura.
Thanks. Just a quick process question. Do I have to click answer live?
No, I'm
okay.
Right now I'm saying it and I'll click it.
I never know when I'm just talking to my wall or when I'm talking to other people. Yeah, thank you for that question. And maybe I'll start it off, but in the spirit of interdisciplinarity, I would imagine that actually Ellen and Daniel would have a lot of interesting takes on the pneumatic part as well. The short answer is certainly. And a lot of smart textiles work has a lot of interesting applications in soft robotics where pneumatics are used quite heavily. And what was I going to say? Oh, there are these really interesting structures that I've seen, especially when you look at like the yarn level. So when I think about smart textiles, I'm not just thinking about fabrics, but really down to the fibers and the yarn. And one of the kind of old or most original pneumatic artificial muscle is a McKibben actuator, which is actually just a yarn that's braided in such a way that it emphasizes the shape when the pressure changes inside of it. And so that's been something a lot of students, I'm teaching a class right now on these techniques, and I have quite a few mechanical engineers in there. And so it's been really interesting to see when they learn how to spin yarn by hand, what they actually do with it, and they bring really interesting things. But I actually learned pneumatics from Daniel's workshop, and maybe you have some other examples you'd like to share, Daniel.
Yeah, I mean, in terms of soft robots, there's actually a whole ton of exciting new developments, especially in how to fabricate them. And I think that goes back to this idea of how to integrate pneumatics into fabrics. So we've seen a lot of developments now in making custom, like a heat sealing, like CNC stages. So what that is kind of similar to something like a 3D printer, where you put in fabrics, you have a hot tool end, and then you seal that. I can try and see, I may have a small, like a small image of one heat sealing stage. It's so On the very right, you can see some actuators that my student Fernando has been working on together with the Keplinger group in the mechanical engineering department. And you can't see the heat sealing there, but it's essentially building these actuators that in the past, you know, these pneumatics were like hard to cast and make by hand, kind of tedious. But now with digital fabrication tools, you can really like make them in a lot of more intricate shapes. And so it also becomes much easier to integrate them into variables and fabrics. And so we're super excited about that. I mean, in the future, we'd really hope we could have one that just comes out of your like pneumatic printer and then goes into your weaving machine. And the ones that I was showing were not pneumatic; they're electrostatic hydraulic, but you know, the fabrication is kind of similar. So, yeah.
Daniel, we couldn't see it. We could only see your slideshow, and so.
Oh, I see.
Try again while I tee up the next question.
Or I can answer a little bit. So when I was at the Q Center, so one of the research project was the Huggy pajama or the tea jacket. So the idea is doing pneumatic pumping air, particularly for autism spectrum disorder. So when they are overwhelmed by the environment, they could be self-minister, pumping up the clothes. So you can have yourself hug. And so, yes, and we didn't do all the complicated integration, but just being able to make your wearable hugging you is comforting for some people. Yes.
Alan, I think I'm going to continue with you. There's a question from Jackson about what do you think the future looks like in terms of commercialization for accessible, delicate controller units, and how easily could a piece of technology like this be adapted to be used with existing commercial software?
Okay. Hi, Jackson. Thank you for the question. And so when we start doing that, the printed paper marker thing is really powerful. And so we just got a grant. The idea is to send the Instructable or toolkit for the kids and parents at home because they're not going to school, and for them to be able to access maybe simulation online. And the idea about commercialization, that is a good question. I think is accessible because then you could be attaching this to anything. So without complicated AR, as long as you have a camera, then we can have interactions. How would that adapt to any existing commercial software? Well, we are actually using it to trigger different simulation or different things. So imagine without the head-mounted display, we could print it or even color marker. So some people can, if they don't have printer, they can like mark it over, and then you can do the interaction with maybe existing software. We just need to have an API, so we can link that. So we can have people select their marker and then map that to a software. And so we haven't think about commercialization, but I think this is making it very powerful for a lot of people that can access. So some of the project we're doing is like with with cereal boxes and other things, and as long as we can slap a marker on things, people can manipulate visualization or data as well. I'm not sure I answered the question, but I think yes, definitely that's the direction we like to go.
I think you answered it. And Jackson also had a question for Daniel about liking the hot coffee example. And Jackson says, it seems like there would be great use for something like this for people who are visually impaired. And have you explored how this technology could benefit users in terms of greater accessibility?
So I fully agree. There are some really awesome opportunities for accessibility. Actually, Ryu Suzuki, together with Tom Ye, has in the past worked on a paper for making these small swarm robots on a tabletop for accessible maps for blind users. So that's a really good example, for instance, on the research that is happening at CU in that area. And there's currently a PhD student, Darren Guinness, who's working a lot on robotics for accessibility, like these particular like tabletop robots. So we have quite some work in this area also happening at Atlas. But one point that I would like to make is also, if we were to look at current computer interfaces, like we like to do this like thought exercise, like take a laptop or a phone and look at it and then try to derive what the human looks like that is using that. They would probably, we probably wouldn't come up with you know, a person with 2 legs and 2 arms and 10 fingers and having stereo vision, because most of the things that our bodies give us, like this amazing expressivity capability, we really don't utilize very much. So in that sense, I think and I'd like to really stress this, beyond accessibility, really just making computing more enjoyable and more accessible really for everybody is very close to our heart, because right now, like Zoom is good for talking heads. It's not very good if we want to be creative together and work together on a physical project, for instance. And we really think we can do so much better than that, for instance, through augmented reality and haptics.
Thanks, Daniel. And I think I want you to weigh in on the next question as well, which is from Karen about what is the future of tactile building given everyone is separate right now?
That's a really, really good question. So we're currently, I mean, at Atlas, beyond like the research that we do in the groups, also in terms of teaching, you know, we have object and other like physical building classes, and they're actually all being moved online and work really, really well, surprisingly. There is this shift towards making, you know, research in electronics, microcontrollers, and building like that is packaged, that you do in your home, and that is also connected. I think that's a very, very big shift, that now we can actually connect these devices quite easily to each other. We can debug them over the internet. I think what's missing from it in this tactile building is not so much that connectedness, that technology of like having the right IoT infrastructure, but really that like having that expressivity of the human body, going beyond like the webcam and really feeling I'm sitting next to my collaborator, next to my colleague, and working together on something.
Yeah.
Sorry.
I was going to add something too, but Ellen, you go ahead. I'm excited.
I'm excited. I'm about to jump in because previously when I showed the printed paper marker, so with the paper, with the marker, and then you are actually manipulated. That's a tangible things. You can building stuff. So one of the things, the example of company A sold 20 airballs. So those are sonification. So even for people who are visually impaired, they could be holding their things and manipulating, feeling it as well. So I think the tactile is expanding to many things. And so one other thing my group is doing with the physics simulation right now is to make this accessible. So we can give people the tool of marker and paper, and then they could be manipulating, moving the curve, sensing the data or simulation. So I think the future is everything could be interactive, and to me that's very exciting. So the tangible thing could be beyond just complicated object, could be anything that you plug it on your mug, plug it on anything. Okay, Laura, your turn.
Well, I was just going to say I've been teaching a class called Soft Object this semester, and so it was a bit of a shock having to do a hands-on class online, but what we ended up doing is sending every student a kit of the equipment and materials that they just wouldn't be able to get. So you can't often buy stainless steel in raw fiber, or all the yarns we get for electricity, you have to have a German speaker order them for you. So Daniel has been our German speaker. So some of the hard to source resources we give to the students, but they've been doing really amazing things by kind of changing their perspective of their home as a kind of fabrication space. And so we had one student who realized that you can make a really flexible material from flax seeds that they were soaking. Another student I just met with told me that she was able to make apple leather. And that since apple leather has a lot of citric acid, it actually conducts a whole lot of voltage. And so she wants to make apple leather based batteries for her project. So in some ways, I'm actually finding that we're getting more inspiration by digging through the like junk drawers in our houses than necessarily sitting in a room full of 3D printers. And that's been really encouraging in a lot of ways.
Thanks. How do you handle usage of expensive tools that are shared? Do students still visit the school to use the 3D printer, laser cutter, etc.? Or have students just been more creative to not have to use those tools?
Both. So yeah, some of the equipment is at school, so they can still access, and some of them are making whatever they have, or if some of the small equipment, we let them bring them home so they can do their printing. Yeah, so all of the above. So people are very creative.
Yeah, everyone's had to be very nimble this semester. We're changing and changing again.
Yeah, I was gonna say we have a $40,000 loom that weighs 1,000 pounds. So we've used our lab calendar to just coordinate that one person. You can only have one person weaving at a time anyway, but it's actually been, hasn't been too bad, as now you just have a more quiet studio to work in.
Okay, I want to answer Robert's question. He asked, would paper disappear? Would paper company survive? And yes, paper would not disappear. Paper would stay forever, and I think company will survive more than just whatever you're doing. Of course, I'm biased because we are using paper as an interface. So as long as you can draw, and I think people still love the freedom being able to draw, to paint, and being able to trigger that for technology. Like everybody have a camera now, or you can be in front of the shop and having paper or paper clothing or paper everything. So definitely paper will stay. I don't think it will disappear. That's my opinion.
I have paper yarn sitting next to me, which is really amazing.
I like this question from Matthew. Any exciting new changes at Atlas? Hopefully everything that we've said today is part of an answer to that. But I think I've been just really inspired by the level of creativity during this time. And I think it's a testament to the community that has grown over the course of the last 10 or 20 years, depending on when you might have been an alumni of our program. And I think the level of research and the engagement of students in the research has continued to grow. And I think that's been the most exciting change for me, but others could certainly weigh in on that.
I mean, I think one just really exciting change that I've seen at Atlas is essentially in this whole like crazy year that we've experienced with the pandemic, the lockdowns and everything. It's really amazing to see everything that is like coming out of it in terms of new inventions and being extremely proactive and positive in terms of like how can we take this situation and kind of make something new out of it. So we've seen a lot of things in terms of, for instance, make at home, you know, this what we were talking about earlier. That's something like now we actually have to do it, and so we're thinking through it every single day. We're like Ellen is doing, like we use paper at home to make like new types of interfaces, like super low-tech tools that we now are forced to. But also it's kind of exciting to think about, like, you know, after this, after like society has gone back to in person, what can we take from the tools that we've developed now and really move forward from that? What do we need to do in person, and where have we suddenly developed amazing new tools and robots and interfaces that we can go, you know, and make more sustainable, more exciting remote meetings happen, for instance. So pretty psyched about that.
Oh, Karen, you're You're my ringer. You just are asking all the questions that I want to answer. Karen asks, how can we best stay in touch with what your labs are working on? And so I am going to share my screen. Can everyone see that? Yes. Okay, great. So if you liked what you saw here today and you want to learn more, one of the best ways would be to come to our virtual Atlas Research Showcase, which is on Friday, October 16th from 3 to 4:30. And be on a lookout for an email from Erin that will have all of the information from this slide, but you could scan this code or go to this link to find out more about the Research Showcase and sign up for it, and also to get on our mailing list, which would be a great way to stay connected. And with that, I want to just thank all of my colleagues for joining today. Thank Erin for putting this on, and especially thank all of you for coming. And I'll turn things over to Erin.
Awesome. Well, huge thank you to you, Jill, and Laura, Ellen, Daniel, for really giving us an amazing look into the research that you and your students are engaging in your labs at the Atlas Institute. This was a super inspiring and informative hour, so we really appreciate your partnership. And also want to thank all of our participants who joined us today. As Jill mentioned, please do be on the lookout for an email from me so that you have that follow-up information on future ways that you can engage with Atlas. And we'll also let you know of some future upcoming alumni events that we have planned for our College of Engineering alums as well. So thank you again, everyone, for joining and listening in today. We hope to see you all again soon. Thanks so much.